Hi, welcome to all. In this video, we are going to see what is current, what is voltage, what is power, what is electrical energy, etc. with an example of water flow from a water tank concept. Now we are going to see what is current. To understand what is current, let us see this electrical circuit. This is a battery or this is DC generator, anyone we will take, and this is an switch. This is an ammeter which will measure the current flow through this circuit. This is a electrical device which is fan. Okay, if we operate this switch, the fan will rotate. To understand this concept clearly, we will see one example: water circulation from this water tank. If I operate this valve, then fan will rotate, water will flow. Since the fan is kept in the water flow direction, fan will also rotate. Now I am going to operate this switch. Since the switch is operated, the electric charge is flowing through this circuit. This ammeter will measure the current. This fan has two terminals. Every electric device has minimum two terminals. These two terminals is connected across the battery, which is also having a two terminals. So this fan is rotating. This is just similar to a water flow. Now I am going to operate this valve. Since I have operated this valve, water is flowing. Since the fan is kept in the water flow direction, the fan is also rotating. Now what is current? The flow of electric charge is known as current. It is just similar to a water flow. Okay. This electron flow or current flow, which is similar to a water flow, is known as current. Now let us see what is potential difference. Okay, consider a power source. Either it may be a battery or a DC generator. As told earlier, every power source has minimum two terminals. Okay, say these are the two terminals. Okay, now these terminals may be in 0 voltage. Say 0 voltage. Then this may be in 200 voltage. Then the difference of voltage is 200 minus 0 voltage equal to 200 minus 0 voltage equal to 200 voltage. Okay, this is known as potential difference. The unit of potential difference is voltage. This potential difference is 200 voltage. Now let me operate this switch. Since I operated the switch, there is a electric charge flow. It will take 1 ampere current. Okay, now let us, to understand this concept, this 1 amp depends upon this voltage. Okay, now to understand this concept clearly, let us compare this circuit with the water circulation principle. This is the water tank, and this level is 5 meter, and this level is at ground level 0 meter. Then the level difference is 5 meter. 5 meter minus 0 meter equal to 5 meter. This level difference is just similar to this 200 voltage. Okay, now let me operate this switch. Now I operate this regular valve. Then there is a water flow. This water flow depends upon this level difference. Okay, now let me increase this level difference from 5 meter to 10 meter. Then what will happen? Water flow is increased. Okay, this water flow depends upon this level difference. Similarly, if I increase this voltage source, if I replace this voltage source from 200 voltage to 400 voltage, what will happen? If I replace with the 200 voltage to 400 voltage, then the current also will take more, from 1 ampere to 2 ampere. Before replacing this voltage from 200 voltage to 400 voltage, we have to ensure this electrical device voltage also similar. Okay, if I increase this voltage from 200 voltage to 400 voltage, this electrical device should withstand it. We have to ensure it. Okay, now let us come to one conclusion. This level difference is similar to this potential difference. And the second one is this water flow depends upon this level difference, and this current flow depends upon this electric charge flow or current depends upon this voltage. Okay, now let us see what is resistance. Okay, This is a lamp which has its own resistance. This resistance will oppose the current flow through it. Let us compare it with the water circulation. If I more close this valve, then what will happen? The water flow will be less. Similarly, if there is this resistance is more, current will be less. Now let me close this circuit. Consider the circuit is closed. This resistance is say 200 ohm. Then what is the current? Current will be 1 amps. Okay. Suppose if I reduce this resistance, what will happen? If I reduce this resistance to 100 ohm, then current flow will be more. That is 2 amps. That is, when there is a valve is less closed, then more water will flow. Then less resistance, more current will flow. Okay. Now let us come to one conclusion. This resistance will oppose the current flow through it, and the second one is if the resistance is more, current will be less. If the resistance is less, current will be more. Now let us see what is power. Consider a lamp. It is a 200 watt lamp. If I close the circuit, what will happen? The current will flow through this lamp and it will take 1 ampere. Okay. Then the power developed will be the voltage applied across this lamp and the current. Okay. Then 200 watt into 1 ampere equal to 200 watt. Okay. The power developed by the lamp will be 200 watt. Suppose if I replace this lamp with a 400 watt, then what will happen? Then the current flow will be 2 amps, then 200 voltage, the voltage applied across this lamp is 200 volt and current flow through this lamp, that is 2 amps, 200 volt into 2 amps equal to 400 watt. Okay. To understand this concept, let us go for the water circulation principle. The power developed by the fan depends upon this water pressure and the water flow, the quantity of water impinged on this fan. Okay. Similarly, the power developed by this lamp depends upon this voltage and the current. Now let us conclude. The power depends upon the power of the fan depends upon the water pressure and the water flow. Similarly, the lamp power depends upon this voltage and the current flow through it. And the power developed equal to this voltage multiplied by this current. Now let us see what is energy. Okay. This is a lamp. Now we are going to find what is the energy consumed by this lamp. If the applied voltage is 200 volt across this lamp and the lamp is continuously switched on for 5 hours. Okay. To understand the concept clearly, as usual, we will go to this water tank principle. If I open this valve, then water flow will be there. The total outcome of this water will depends upon the water pressure and the water flow rate and the duration of the water flow. Okay. Similarly, the energy consumed by the lamp shall depends upon this voltage and the current flow through the circuit and the total duration of the hour. Now let me close this circuit. What will happen? Current will flow and it will take 1 amps. Now what is energy? Energy equal to this voltage, this current and this total duration. Okay. Then what is the energy consumed by this lamp? That is voltage into current into time duration, that is 200 voltage into 1 ampere into 5 hours. That is equal to 1000 watt hour. 1000 watt hour is a very small unit. 1000 watt hour is equal to 1 kilowatt hour or 1 unit. We are paying to the government company for this unit only, for kilowatt hour or unit only, not for voltage or current. We are paying electricity amount only for the energy, that is unit consumed. Okay. Now let us conclude. The quantity of water outcome depends upon this water pressure, water flow rate and the total duration of the water flow. Similarly, the total energy consumed by this lamp depends upon the voltage applied across this lamp and the current flow through this lamp and the total hours of lamp in switched on condition. Okay, that is voltage into current into time duration. That is known as energy consumed by this lamp. Now let us see what is closed circuit. Let us consider one lamp. This lamp is connected across a power source, that is either it may be a battery or a DC generator. When I operate this switch, okay, the electric charge, the electrons will leave from one terminal of the power source and it will come through this ammeter, through this device, and again the same electron will reach the other terminal of the same power source. This is known as closed circuit. To understand this concept very clearly, let us see an example of water flow from a water tank. The water available in the water tank will flow if you operate this valve. This water flow will impinge on the fan. Again the water will come back to the same water tank. Okay, the water leaves from the water tank and again it reaches the same water tank. Similarly, the electron flow from the one terminal of the power source and again it reaches the other terminal of the same power source. This is known as closed circuit. Let us finish this video with one golden verse. The simple mantra to be happy is to make others happy.